Hey everybody, so it's Mr. Murphy here. Today we're going to be doing a little bit of a lab demonstration for our asynchronous work, and you're going to be responding to it, okay? So without further ado, we're going to feed some yeast, okay? So first we have, some nice warm water. We have a balloon. We have a packet of yeast. We have corn syrup, which is basically just sugar water, kind of, okay? So what we're going to do, okay, is we're going to take our active dry yeast and we're going to add it to our water. Now, our yeast are alive. They're a unicellular organism. They have one cell, which means they're going to be a great model to see how food is processed on the cellular level, okay? So our corn syrup right here, okay, is going to be our food, and our yeast are going to be our organism that's going to eat that food, okay? So now all consumers, organisms that get their energy by eating, okay, are going to process food pretty similarly at the cellular level. So we're going to investigate that today with these yeast. But a lot of the stuff that applies to this yeast would apply to a larger organism, like a human being or a any kind of pet that you might have. Okay, so first of all, we're going to add our corn syrup right here to our bottle. We're going to add just enough to cover the bottom, really. Okay, this is going to be our food for our yeast. There's going to be plenty of food for our yeast for a while. There we go. Okay, let's call it there. All right. Then we're going to take our yeast. We put in warm water. Okay, cold water would not be good for our yeast. It would not facilitate them eating. It might even kill our yeast, which means you wouldn't be able to see our results of them eating if they are not alive. All right, here we go. So we're going to add our yeast right here. We're going to make, first of all, though, I want everybody to take a quick observation of this yeast and just look at it, okay? Note the color. Think about, it's pretty thick if you look. It's hard to see, but it's pretty thick, okay? It moves around, all right? So we're going to take our yeast. We're going to add it to our sugar, which is clear and white, all right? Here we go. Okay, it's got lots of clumps. This and then it's a little bit smoother. We used a little bit more water to dissolve it. It might have been a little bit less clumpy, but it's fine. Don't worry about it. It's incorporated, I mean. Not technically the way. Okay, so here at the bottom, we kind of see just like, it just looks exactly like that jar of yeast from before. Okay, we're going to stir it a little bit to help combine it and get things going. And then the next thing I'm going to do is I'm going to take this balloon. Okay, and I'm going to put it over the top of our water bottle, if I can. Okay, so now we got a nice seal. Do you guys see how it covers the whole end of the water bottle? So none of the gas in our, this would be what's called a closed system. Okay, a closed system means that the air can't escape this bottle. Okay, if I left the balloon off, that would be an open system. So right now we're saying everything that started in our bottle is going to stay in our bottle for the whole experiment, and nothing new is going to enter into the bottle. Now this might not be a perfect airtight seal, but it's pretty close, okay? I can already kind of feel it. It's a little bit harder. See, if I squeeze the bottom, the balloon fills. That means we have a good airtight system because the air can't escape. It just moves from the bottom to the top. Okay? So that shows us that we should be good, okay, to go ahead and let this sit for a while and see what happens as our yeast processes the sugar from our light corn syrup. Okay? So right now we're seeing what happens as our yeast starts to eat our corn syrup, what is going to happen in this container. Okay? Perfect. And then as we go forward in this unit, we're going to do a couple different variations on this. So we're starting with just sugar and seeing what happens. We might try some other stuff as we move on and see if it's able to process it the same way or we have different results. But today's just our baseline experiment because we're just starting this unit after we finish growth of organisms. Okay, so we have our nice closed system, which has no ability for the air to escape. If the air could escape, that would be an open system. Okay, if you can't tell already, that's probably going to see that on your lab sheet. All right, perfect.